Hello, everyone. We are going to do some multiplicative comparisons today. And when I look around me, they are all over the place. For example, I have a water bottle right next to me. Okay. And then I also have this pretty little flower. Okay. Well, the flower is in a vase. And the vase is not as big as my water bottle. My water bottle is bigger. And I could actually use a multiplicative comparison to say how much bigger my water bottle is than the actual vase. I might say the water bottle is twice as big as the vase. It is 2 times the vase. So if I put 2 of these vases together on top of each other, it'd be the same as my water bottle. Or the vase is half as big as the water bottle. It's half the size. Okay? They're all over the place. All right, let's check out some right here. So you will practice some of these by first looking at some rectangles. So it says first put your name. So I'm going to go ahead and click in and write my name. Then it says to use the blue tiles down here to create a rectangle that is 3 times as long as the red tile. It needs to be 3 times as big as this guy right here. That means the blue rectangle will be as long as 3 red tiles together. Okay, so if I go down here and oh no, I can't pull that over. But if I have 3 of these put together, that's what I need. I need something that is 3 times as big as the red. So I'm going to say, okay, here's my blue. Have I made it 3 times as big as the red? No, I've only made it the same. How about if I put 2 of them there? No, that's 2 times as big. If I put 3 of them there, now I am at 3 times as big as the red. So how do you know that your blue rectangle is 3 times as long as the red tile? I know the blue rectangle is 3 times as long as the red tile because I made my blue rectangle 3 red tiles in length. Yes, I made it, whoops, that needs a G. I made it 3 red tiles in length. That'll make it 3 times as big. Cha-ching! Okay, take a look at this giant. That guy looks giant compared to this little person. Just like in the class, in the school, you might look over at the middle school side when you were a first grader and be like, oh my gosh, there are giants over there. Whoa. Okay, the 6th, 7th, and 8th graders look like giants. So Sam here says that the giant is 3 times as tall as Jim. That means that 3 Jims stacked on top of each other will be the same as the giant. Do you agree with Sam? Okay, well, let's see. I'm going to take these little Jims. Here we go. There's 2 Jims on top of each other. And here's 3 Jims. Well, Sam says the giant is 3 times as tall as Jim. Is he? Well, that didn't work out. They aren't the same. He's actually more than 3 times. I pull over another Jim, and the giant is actually what? 4 times as big as Jim. So Jim is what? Jim is as tall as the giant. Is he 4 times as tall as the giant? No. He is a 4th as tall as the giant. The giant is what? 4 times as tall as Jim. Then you can write in, do you agree with Sam? I do not agree with Sam because because when I stacked up Jims, it took 4 of them to get to the top of the giant. This means that the giant is 4 times as tall as Jim. Jim is only a fourth as big as the giant. He's only a fourth. He's not half. He's a fourth. Whew. Okay, let's check out some more giant stuff. Whoa, this is outside the giant's door. So now we have some things to compare. Like I could say the red-haired kid is how many times as tall as the envelope? Well, he's taller than the envelope. He is, how many envelopes would we need? We would need 2. So the red-haired kid is 2 times as tall as the envelope. Can you find more? Yes, you could. How about the shovel is how many times as tall as the hammer? The shovel is taller by how much? How many hammers would we need? 1, 2, 3. Be 3. So you find your own on that last one. Okay? Let's take a look here at this one. Now it gives us some more information. So we know from earlier that it took how many Jims? It took 4 of them. Okay? So now it actually tells us Jim is actually 48 inches tall. This guy right here, he's 48 inches. So how tall is this giant? Well, it tells us we could use a picture from us drawing this out, our mathematical ideas on paper, and insert it into this document. I could type out my idea here in words, or I could use the number line or the ratio table. Okay? I'm going to go ahead and show you the number line. So if I were to use the number line, I know that Jim is 48 inches. So I could go, okay, well, if I go to my whole numbers, well, and I take a jump of 48, that is a big jump, right? It's not even going to fit. So you know what? I'm not liking having numbers on there. I'm going to take away the numbers. And I'm actually going to take away the tick marks. Watch what I'm going to do. I'm just going to do a jump. And I'm going to label it, this is 48. So here is Jim. But the giant is 4 times that. So I'm going to make another exactly the same. And another, and another. I need 4 of them. And each one of these is 48. And this one's 48. And this one's 48. Now I have it. So now I'm going to go ahead and I can draw on this. And say now I need to add them all together. So I have 40, 40, 40, and 40. So I could write that out. I have 4 40s. Okay? 4 40s. So if I have 4 40s, that'll give me what? Let's see. Let me write this out. And another 40. So 40 and 40, that'll give me 80. Another 40 and 40 is another 80. Add those together. Well, 8 and 8, I know is 16. So this will be 16 tens or 160. Is that the total amount? No, because I still need to add on all these 8s. So I have 4 8s to add up. Okay, and that's the same as 4 times 8. Well, 4 times 8 means 8 4s together. Well, 2 8s. So if I just double an 8 and then add another double 8, that'll give me 4 groups of 8. And double 8 we said up there was 16. So 16 and 16 together will give me a total of 32. So now if I put my 160 and my 32 together, so 160 plus 32, I'm going to get a total amount of, well, I have 100 right here. Now how many tens do I have? I have 6 tens and 3 more tens, which will be 9 tens. And then I have 0 ones and 2 ones, which will be 2. So I have a total of 192 inches. So I'm going to share that, copy that image, right click, copy, go back to my slide, and I could paste it in there. Okay, paste my work in there. All right. If you'd rather not use the number line feature, don't use it. You could use the ratio table. So I'm going to pull that over and show you what that might look like. So here I have, I'm going to take this out. So here I have Jim, and then I have the giant. I'll just put G. Now if Jim is just 1 inch tall, the giant would be 4, because he's 4 times that. What if Jim is 2 inches tall? Then the giant would be 2, 4, 6, 8 inches tall. We just double. What if I double again? And I say Jim is double 2. That's 4. Well, then I'd have to double the 8, and that's 16. Now what if I double again? So 4 and 4, that's 8. But then I would need to double the 16, and I would be at 32. Am I done yet? No, I've just gotten the 8 so far. I need to get 40. So let's go straight to 40, shall we? So what if I go 40? Well, if Jim is 40, I'd have 40 plus 40 plus 40 plus 40, which is what we have right here, which turned out to be 160. So now I can just add this chunk to this chunk, and I will get my 48 inches. So 8 plus 40 is 48, and then I'd have to add 32 and 160. And when I add those together, I'm at 192. So now I've actually solved it 2 different ways. So the giant here is 192 inches. And our equation, there you could have some different equations. Up here in the ratio table, we did our 160 plus 32 to give us a total of 192. Okay? All right, you have 4 problems to pick and choose from. There's even a challenge one. So I'd pick one from 1, 2, and 3, and if you want more of a challenge, try another, number 4. All right, good luck.